Hello everyone, today I am Dewa Thapa of 3rd semester from Chemistry Department, roll number 21NS0301. Would like to present my presentation on the topic photoelectric effect. We all are familiar with this topic, but today in this video we will discuss on the details. Here is the introduction. The photoelectric effect was discovered in 1887 by the German physicist Heinrich Rudolf Hertz in connection with work 0 to the power 5 and radio waves. Hertz observed that when ultraviolet light shines on two metal electrodes with a voltage applied across them, the light changes the voltage at which sparking takes place. This relation between light and electricity was clarified in 1902 by another German physicist, Philipp Leonard. He demonstrated that electrically charged particles are liberated from a metal surface when it is illuminated, and that these particles are identical to electrons, which had been discovered by the British physicist Joseph John Thomson in 1897. Further, Einstein was finally awarded the Nobel Prize for Physics in 1927 for explaining the photoelectric effect. Uh, in 1931, Albert Einstein was nominated by a Nobel Prize for his novel work in photoelectric effect. So we will discuss now what is photoelectric effect. When light when light wave of sufficient energy incident on a metal, then electrons are ejected from its surface. This phenomenon is known as photoelectric effect. So let's uh, so let's see how this happened. We will take plates. We will take metal plates, and also a source of light is present out here. When the light is allowed to incident the metal plate, then the electrons from the surface of the metal get ejected. Fine. So these electrons are known as the photoelectrons because these are ejected by the actions of photons. Now the questions arise: light of any energy can ejected the photoelectrons from the surface of metal. So the answer to this question is no. Basically, each metal has certain work function. This work function is nothing but minimum energy which is required by the electrons present in the surface of the metal to get ejected from its surface. Fine. So the quantum energy or the frequency of the photons must be either equal or greater than the particular work function in order to have a photoelectric effect. We will highlight. So I highlight some important points. So photo effect phenomenon in which electrically charged particles are released from or within a material when is absorbed electromagnetic radiations. This effect is often defined as the ejections of electrons from the metal plate when light falls on it. The radiant energy may be infrared, visible or ultraviolet light, X-ray or gamma ray. The material may be solid, liquid or gases, and the released particles may be ions as well as electrons. The phenomenon was fundamentally significant in the development of modern physics because of the following questions it arises about the nature of light, particles versus wave-like behavior that were finally resolved by Albert Einstein in 1905. So, friends, Sutton's laws are associated with the theory of photoelectric effect. So let's move further in order to understand the three laws of photoelectric effect. Uh, We have already recently discussed the first law, which states that photoelectrons are ejected by a metal surface when the frequency of incident radiations become equal or greater than the work function of metal. So HF is greater than equal to phi. So your phi represent phi phi represent the work function of metal, and h represent h has the Planck's constant, and f is the frequency of the incidenting photons. We have already discussed the reason behind this particular law. So uh, so now let's move further. Second law. uh, the number of photoelectrons emitted per second is directly proportional to the intensity of incident radiations. As one incident photons on the metal can eject only one electron from its surface. So let's move for the third law. The third law states that the maximum energy of photoelectrons do not depend on the intensity of incident of light, but relies on the frequency of light. With this effect, Einstein's photoelectric equation is associated. So now let's have a look towards that. Okay. Uh, so we know the quantum energy is energy of light. We know the quantum energy is the energy of light particles, and it is given by W is equals to HF. So we have already discussed that H is the Planck's constant and F is the frequency of incidenting photons, and the value of Planck's constant is nearly around 6.626 into 10 to the power minus 34 joules second. So the work function of the metals, which is denoted by phi, is given as here h into f naught. On this and this f naught is minimum frequency, which is f naught is the minimum frequency which is required to cause photo emission. This f naught is sometimes termed as the threshold frequency of the metal. Also also the kinetic energy of the photoelectrons is given by the difference between quantum energy and work function. So kinetic energy is equals to W minus phi. So basically kinetic energy of photoelectrons is nothing but the extra energy which is achieved after subtracting the work function from quantum energy. So on substituting the value of quantum energy and work function in this particular equations, we will get the kinetic energy is equals to hf minus h f naught. Also we know the kinetic energy is given by half mv square. So substituting this value, also we will get half mb square is equals to hf minus h naught. On transposing quantum energy to transposing quantum energy to left hand side left hand side, and kinetic energy to the right hand side. This part so we will get the particular equations. Okay, so and this equation is known as the Einstein photoelectric equations. So now further we will discuss the applications of photoelectric effect. Uh, number one, photocell is the most important applications. We all are familiar with these applications. It is most commonly found in solar plants. It works on the basic principles of the light shrinking the cathode, which causes the emission of electrons, which in turn produce current. Photomultiplier tube makes use of photoelectric effect to convert light intensity into electrical current. We know about these applications. So now further, photoelectric effect also found applications in photocopies. Yes, light meters, photodiodes, and phototransistors. So further, scintillators. A scintillator is a device that emits light when it attracts radiations from either source in a lab or a cosmic source. So in this video, we will see the Einstein photo